Hi and welcome to RC Copter Love. Today it's a special video because we have a special guest from Germany, Jonas Wackershauser. Hi Jonas.
Hey everyone.
Jonas, thank you very much that you took your time. I think you are terribly bored in this summer, nothing is going on.
No, nothing would ever be going on with this company.
So, Jonas, I would like to talk with you today about the M2 V3 PRO. And in my opinion, you managed to fulfill with this heli a kind of mission impossible, because it combines some of, I was looking extra in the dictionary, contradictory properties which are usually not to be combined. The first one is that this heli is as small as the M2 EVO and the M2 EVO Mark II, but it flies, and not only I think this way, it flies like a 700 or 500 heli. How did you do this magic?
Oh, that is a good question. So a big part of that comes from the OFS 3 flight controller, which we developed from the ground up for the M2 series of helicopters. And this really gives the helicopter a lot of stability because we have these sophisticated control loops that we designed for small helicopters. But it's also in the airframe design, because the rotor head is mission specific for this helicopter. The rotor blades have been optimized. The entire helicopter is, let's say, very highly optimized to give this kind of flight performance. With every part, we reduced the weight, we improved the strength, we aimed for a helicopter that would basically be built to the standard of a larger helicopter with the experience from M7, M6, M5, also M4, but still retains this very compact package with a very light weight. So I think these things combined aid the helicopter in flying the way you described.
Okay, so my next question is even connected with this, because I am completely stunned. I have the AquaRC simulator. It is a little bit aged, but you were involved in this, and this simulator has unbelievable realistic flight performance. So I'm doing sometimes the thing that I'm a little bit on the simulator trying something, and later I'm going on the field and I'm always shocked how similar this feels. I have still in my body, in my fingers, I have this muscle memory, how it felt in the sim. Then I'm going on the field with this little beauty, and it is really, I don't know, sometimes I have even the feeling it is, of course, difficult, but I'm showing this helicopter to my wife in front of the camera, that it's even flying better than in the simulator. And that is the thing, when you look at this helicopter, the M2 EVO Mark II, it is a lot slower in the reactions, in my opinion, even although I was programming my flight, the agility and the speed rates very high, it's still a little bit slower in the reactions than the M2 V3 PRO. But at the same time, the M2 V3 PRO is really unbelievably stable. So agile and stable. That is also something that is for me a wonder, a miracle.
So the agility mostly comes down to very, very low inertia of the helicopter. If you compare the EVO Mark II and the V3 PRO, especially the tail on the V3 PRO, it is made from carbon fiber with a very lightweight tail motor mount. The tail motor is smaller and lighter. So this reduces the inertia on especially the pitch axis. So when you give an input, you have less mass to accelerate that's far out, which requires a lot of torque. So that gives the kind of very quick reaction that you're seeing. The stability, then again, it mostly comes from the control loops. You could do a fun experiment if you're very, very brave and put PID on your main rotor to 0 to see how much stability actually comes from the airframe. Maybe that's a video idea for you. Flying a helicopter completely manually, but be warned, it's not an easy feat. So you get an idea for how much stability comes from the helicopter. But yeah, most of the stability is really artificial. The rotor blades help a little bit. They are a little bit more flexible on the V3, the Apex 190 that we made for it, which helps a little bit with the stability of the helicopter, especially at speed, because effects like the symmetry of lift, rotor disc, flatback, that kind of stuff can come right out of the blade and does not have to be compensated for by the control loop. So you get more margins for the stability. But yeah, so the reaction, mostly inertia, the stability, mostly electronic.
So I have to say, you did really an amazing job with this.
Thank you.
I'm all the time stunned. I'm often going out with the M2 EVO Mark II and the V3, and I'm really shocked. And I have this feeling that even in the M1, because it has the OFS 2 flight system, it is a little bit similar, more similar to the M2 EVO Mark II, because sometimes I have the feeling that when I give a very, very, very small stick input in the cyclic, that you have to overcome some kind of Widerstand. What is in English?
Resistance.
Resistance. And this is completely not the case with the M2 V3 Pro. So it's when you are going into roll or something, especially when you fly these models one after the other. If you are flying only the M2 EVO Mark II, you don't feel this, because you are used to this helicopter. But when you are comparing these two helicopters with each other, it is to be felt. Can you say that you feel something similar, or is it my imagination?
Well, there is a dead zone in the OFS 2. So when you move the stick initially, you actually do not get a reaction for the first 5% of the travel. And only then it starts with a lot of expo, which is something we specifically eliminated for OFS 3 because people were complaining about this. What you're possibly seeing is the differences in the rotor head geometries between the EVO Mark II and the V3. The V3 has a steeper geometry, which means that for a given servo angle, you get more blade angle. So when you deflect the stick, and the servos, they have a speed limit. So they move at, I don't even know what our servos are rated for, I think 0.07 for 60 degrees, something like this. And the servo moves at its maximum speed because the flight controller is trying to accelerate the heli as quickly as possible. The V3 Pro will get to the desired blade angle quicker. So that also can contribute to you feeling that it takes longer for the EVO Mark II to accelerate, because the V3 Pro simply gets the blades to the desired angle quicker.
Okay, that is really the summing up what I felt in your better words. Also, you did a great job in this because this is something I was missing sometimes a little bit, especially when I'm now a little bit more advanced than I was a year ago, because then you need this, and especially around mid stick, this was the most feelable for me. When you're doing something like scale fly or very precision flying, there was always something I had to overcome, and in the V3 Pro this is completely gone. Like in my bigger helis, like in the M4 Max for instance, and the M4, of course, how you adjust your flybuzzer system, but it's much more similar. in this meaning.
So let me ask you a question.
Yeah.
Because you're still very much in the process of learning how to master different orientations and flips and rolls and stuff. The V3 Pro is very, very agile, very direct, but what I found, because I sometimes also fly with someone who's just learning to fly helicopters, and I've let them try the EVO Mark II and the V3 Pro, is that they were overwhelmed with how quick the V3 is. Do you feel like that the kind of steadiness and slowness of the EVO Mark II can help a beginner more than the quickness of the V3 Pro, or is the V3 Pro an advantage for you in learning?
For me, at the stage I am now, I would definitely say that the V3 Pro is a big advantage, because it is part of my history in how I was learning. I never was using any expo I had to program on my radio. I was always using the fastest possible settings on the old M2 M1 and the V2. I'm on speed. I'm even on 9 points, 9 blinks. So 9 blinks, and agility I'm at 7 blinks, and no expo and nothing. So I'm used to extremely small stick inputs, and I love this. I describe this feeling. I made once a description to a friend. It feels, when you have a heli with very fast controls, it feels as if you have a piece of Kreide. Was it in English?
Chalk.
Chalk. And you write something on a table in the school, and exactly what your hand is doing you see on this wall. You know what I mean? So I have with the M2 V3 Pro, I would say the most amazing for me, it is the best word is describing, it is predictable. It is completely predictable. I get what I do and what I do expect. And I'm sure you were asking in the beginning if this would be helpful. I think not, because in the beginning, first of all, you don't know what to expect because you are learning this all. So you learn the expectations, you learn the movements of the helicopter. You are learning. You are only having an idea what the helicopter will do, because you didn't do it for a long time, you don't have enough experience. And I even think I was starting with the ready-to-fly transmitter. The first 2 years, really, it was this T6 transmitter. And after having the first programmable radio, I found it awful. The feeling, you don't have any feeling. So I remember my first flight with a programmable radio without any expo. I was doing such things, my helicopter was doing such things, and I was not even aware that I was moving the sticks, because it was all buffered by the expo, by the deadband. And but after 5 flights without any deadband, or at least only maybe the small amount of deadband that was in the OFS 2, but it's not comparable with the OMP protocol and the T6 transmitter. I have to tell you, I was not able even to fly. I would not be able to fly the helicopter in a proper way. Just, okay, of course, starting, taking off and landing, everything. You can do everything, but to do the things I'm doing now, I would never be able with the T6, and I feel the difference. So for me, this is clear. I think a new pilot could also be very happy with the M2 V3 Pro, because he could put in some expo in his radio, for instance, at the very beginning, but he could take it step by step. He could reduce this until he gets this direct feeling I love now so much. So he could start with this helicopter, and and continue later. So, what do you think about this concept?
That is very good info because, you know, me learning to fly, that was 15 years ago. So I don't really have a concept of that anymore. And that kind of insight is always very valuable. But sorry, I didn't want to break up this entire conversation like that. That was just something that came to mind that I find really interesting.
Very, very good. Jonas, so my next question is, you were able to reduce the weight on this small helicopter, but it is, how many grams were you able to reduce?
So the flying weight of the M2 EVO Mark II is usually 345 grams. The M2 V3 PRO without the receiver and Bluetooth module is going to be 320 grams, so 25 grams.
25 grams. So this is not a lot, but it's a lot for a small heli. How difficult was it to reduce this weight?
Well, it is a completely new design, so we did not carry around any of the weight from the old parts, but at the same time, the last 5 grams that I reduced, because from the beginning of this project, I set a hard limit of 320 grams ready to fly. And eventually in like January of this year, we were at like 325 grams. And I was like, nope, not good enough. We need 320 grams. And the last 5 grams that I saved took 40 hours of work.
Wow. 40 hours for 5 grams. So that
40 hours for 5 grams.
That is unbelievable.
Yeah, that is what happens when you set a clear goal that you want to achieve at all costs. And I mean, we did it. At least with the design weight of the canopy, we're exactly at 320. Of course, the canopies are hand painted, so it varies up and down a little bit, but the average M2 V3 PRO is going to be at 320 grams.
Okay, great. And in my opinion, it feels like much lighter, because especially when you accelerate the helicopter in one direction with positive pitch and negative pitch, you throw it around, it feels as if it's light like a feather. So this is also astonishing, and for me part of this mission impossible, because it is not a lot of grams. It is a lot of grams, a lot of hours you put in this, but it feels much more. So great job in this also. Last question from my side is now, when I saw the first pictures, don't be angry on me, I thought, my goodness, this all looks very fragile. These skids are so small and skinny, so especially, I'm showing now to the camera, when you compare it with the M2 EVO Mark II, the tail fin, I was looking at this tail fin and I was thinking it is beautiful, but it might break very easily. And you know, the good thing is nothing breaks. It is, the tail fin is the same, stable and sturdy and tough to break, like on the M2 EVO Mark II. The skids are flexible. You can so what they don't have in massive plastic, they have probably in flexibility. So nothing breaks easy on this helicopter, although it looks so beautiful and fragile. That is also a thing you can explain maybe.
Well, let's put it like this. It's not like nothing breaks. That would be unrealistic to expect.
Okay.
Things still break if you crash, but the way they break is a bit different. Let's put it like this. If you have a crash full on smacking the tail into the ground, what would previously break is the rotor mount would bend, the tail fin would probably break at the point where it extends back to the motor, and your aluminium boom would at least bend. And I'm not an advocate for bending things back. You could continue flying that bent boom, but it would be obviously compromised because the material gets plastically deformed and loses strength. What now happens on the V3 PRO is the carbon boom in a crash where the aluminium would break, it has a bit more strength, so it will hold on for longer. And since carbon cannot plastically deform, at some point it will just break. So this is one of the kind of differences in this. Some parts are made to hold on for longer, but then eventually they will just break when you would have to replace them anyway. Like flying a bent boom is stupid. Also, the mainframe and the rotor head, they were highly optimized via finite element analysis. What that means is you take a part. Do I have some part here that I can show? I don't know. I got no part. But let's just imagine you have like a part and you divide that into tiny little chunks. And every little chunk has material properties and interacts with the adjoining chunks. And then you take the part, fix it at some place in the computer, apply a load in another place, and see how the part reacts. And then the computer will spit out a 3D map of stress, strain, deflection, where the biggest stresses concentrate. And then you can take away material from areas that are not stressed and put more material in areas that are stressed. So when you're working with a given weight for a part, you can distribute this weight into the part in a way that it appears in areas that take the most loads during flight and during crashes. And this is the fundamental principle with which we optimized every single part on the helicopter. The material is distributed in areas where it sees the most load, and areas where it does not see much load, it just got reduced to save weight. And this is one of the secrets, well, not secrets, it's just an industry practice that allows you to make stronger parts for a given weight, or if you reduce weight, keep the same strength.
Okay, great. One maybe additional question, not really planned. How did you come up with the idea to follow the design principles of the M5, M6, M7, or maybe the other way around, even because the M7 was the first of these, and to follow this design from the holes here, for the ventilation holes in the canopy, over the shape of the skids in such a way that it really looks like a baby of an M7? When did this idea come up?
Well, basically, this happened by me finding a design language that works for our helicopters. For example, the M4. I started with the servo rack that arranges the servos around the main shaft, and then a main plate and the side panels. And this design then carried on to M5 and M6, which also have the servo rack, main plate, side panels extending downward. And the basic idea was to just unify our lineup with this design language because we know it works. The main plate on M4, M5, M6 is extremely sturdy. Nobody has ever bent it. The servo axis is super easy because all servo arms are exposed. You can easily access them. The panels going downward from the side plate to hold the components, I mean, that is a given on basically any helicopter, but also not extending them too far upwards. And fun story, actually. One part on this helicopter is due to a friend crashing a prototype very violently, which is a part that does not show up on M4, M5, and M6 yet. It is called the Steven plate because I let a friend of mine fly the helicopter a couple months before release just to see what he thinks. And he crashed it so badly that the main plate bent. And the little plate in the rear that connects the servo rack to the main plate, that is the Steven plate because that prevents this bending from happening. So it was by a crash caused a function that avoids us from bent main plates. So yes, exactly. And it is not unthinkable that future iterations of other helicopters will also include this plate now, because every helicopter we build, it is a learning process. We are learning how to make the best helicopter that we can, with the best strength that we can, that users can crash it as hard as they want without breaking too much. That is the most important part.
Okay.
Like, of course, we still want to sell spare parts, but we also don't want to frustrate the user by having them bend the entire core of the helicopter with the tiniest crash.
Yeah.
So it is a continuous optimization process, but it's all converging into a single design language, which is now basically the same across M2 V3, M4, except for the battery position, M5, M6. M7 is different, but M7 has to be different because 700s have a lot more forces and you need additional bracing, so the frame is a bit different. But yeah, it's all converging against this design really. And also the M1. The M1 EVO followed this design from the beginning with the main plate and the servo rack on top. So that one technically also already follows this design despite not being my design. So this also inspired the M4 servo rack and stuff. So it's all converging.
Okay.
And not doing the same canopy design on all helicopters would also be stupid, because whenever you introduce a new canopy design, people always ask, oh, can I have this on helicopter A, B, C, D? And people want consistency across their helicopters. They love it if their M2 looks like their M7, looks like their M5. So
me too.
It only makes sense to do it this way.
Yeah, great. So talking about the future and this whole evolution, can you say something? Is something in the pipeline? I don't want to press you to something that you should not say, but just is there something you can give a small light on, or better not?
Matthias, you know this. You know that I cannot say anything.
Okay.
Except we're always working on new and exciting projects. And one would be foolish to think that we do not have new projects in the pipeline, but what they are...
Okay. So we keep quiet. So Jonas...
There's no thing.
Yeah. So Jonas, I thank you so much for taking the time. This time we didn't have to sit on the grass like the last time. And I want to tell you that it's a special moment for us, my wife behind the camera, and me, because we just accomplished more than 1,000. It's at the moment, I think, 1,001, or in the time when we publish this video, it will be probably more. But hopefully, but it's a milestone, and it's so good to share this milestone with you, and to go on in the future together. So thank you so much for taking your time, and I wish you that you will always have enough to do, but sometimes also have some time to relax, to have a good time with friends, to fly privately, just for fun, not worrying about things that you have to observe, that you really sometimes... Do you have sometimes the time to go just flying for fun with friends?
Yeah, sometimes. Sometimes I really just fly for fun. I might take a prototype to the field and fly it a bit, but sometimes I really just go out and enjoy myself, because if I stop doing that, what am I even doing?
Yeah. That's a good summing up. We started is because we love it, and it's our passion, and it has to be our passion always. So, Jonas, I thank you very much, and I hope to see you for another meeting, especially at Rotor Life. In Iffesheim. I hope that we can have a sit down together again to make it a kind of tradition. So I will love to see you there, and I wish you all the very best.
Thank you, Matthias. I wish you all the best as well. I'll probably read from you in team chat in like 5 minutes or something. So really saying goodbye would be kind of over dramatic, but I really enjoyed this. I really
Yes.
enjoyed this, sitting down with you, talking about the things we love.
Thank you.
It's fun
That
when
is-
we find the time.
Yes, when we find the time. Okay, so thanks and see you again.
See you soon, Matthias.
See you.
Bye-bye.
See you. Bye-bye. So this was our talk about the M2 V3 Pro with Jonas Wackershauser, the constructor. I hope you liked it, and see you again on RC Copter Love.